Another problem today, that is called minimum swaps. Okay, so here would be you would be given an array of integers and an integer b, and you need to return the minimum number of swaps required to bring all the numbers less than or equal to b together. Okay, you need to return the minimum number of swaps required, and you need not return those like those elements. Okay, you simply need to return the minimum number of swaps here. Okay, suppose the input here is 5, 16, 212, and suppose b is equal to 30. You need to return the minimum number of swaps required to bring all the elements less than equal to b together. Okay, so here the array has 5, 16, 212. Okay, and if b is equal to 30, so if you remove or replace this 200, okay, so that means if you swap this 200, then this all these elements less than equal to b, that is 5, 16 and 12 will be together. Okay, so as we need to swap only 200, so the output is 1 here. Okay, to solve this problem we'll be using the sliding window concept. Okay, so let's see through an example, like how are we going to approach this problem. Okay, understand this problem, like how would be approaching this by code. So here on the left hand you have the code, right hand you have the approach. Okay, so we have a main class. Within the main method we are creating an array of length 7 which holds the value 2, 11, 10, 1, 16, 3 and 4. Okay, the same that you are seeing on the right hand, 2, 11, 10, 1, 16, 3 and 4. Okay, and we are creating an object of the solution class which holds the minimum swap method. We are simply calling that, and we are passing this array and the v value as 9. Okay, and we are later printing the minimum swap required value. Okay, so let's see the solution class, what code we have placed in the minimum swap method. Okay, so first we have created an integer value variable called n, which holds the length of this array, that is 7, and this integer window size is the length of the sliding window which we are going to create now. So initially it's 0, and how we are going to create this window, we are going to check the number of elements in the array which are less than equal to b, and that's going to be our sliding window's length. Okay, so we are looping over this array here, and if the element is less than equal to b, we are simply increasing the window's size, okay, by 1. Okay, so the elements that are less than b here are 2, 1, 3 and 4. So the sliding window size here is 4. Okay, this I have simply kept for printing purpose. I will be later removing this. Okay, so next what we are going to do, we are simply going to calculate the minimum swap required in the first sliding window. Okay, let's see how we are calculating that. So we have initially assigned the start of the index of the sliding window to 0, and end is equal to window size minus 1, that is 4, 4 minus 1, 3. And initially this minimum swap variable holds the maximum integer value possible. Okay, that is this. Later we'll be replacing it with the minimum value that we'll be seeing later. And we have a variable here called bad elements. So what are bad elements? Bad elements are those numbers which we need to swap. Okay, that means those numbers which are greater than b. Okay, we'll see to that, like what's the intuition behind that. Okay, so we are going to check the first sliding window. So we are going to start from 0 until 3. It's going to start from 0 till 3. Okay, so your start is 0 and end is window size minus 1, sliding window size is 4 minus 1, that is equal to 3. So it's going to loop from here to here. Okay, so if we have an element greater than b, that is greater than 9 here, then we'll increase the bad elements value by 1. So in this range we have two bad elements. Okay, we have two bad elements, that is this and this, 11 and 10. Okay, that is 11 and 10. Okay, so these are the two bad elements here. That means elements which are greater than B. So the minimum swap that will be required here, okay, is 2, because if you replace 11 and 10, okay, by 3 and 4, the question says we need to bring the elements less than or equal to B together. Then what is the minimum swap required? So if you need to bring all the elements in this range which are less than equal to B together, that means we need to swap two values here, that is 11 and 10, to bring 3 and 4 in its place. Okay, our solution is not to bring the 3 and 4 in its place, but to find out the minimum swaps required in order to do that. So here the minimum swap simply required is to swap 11 and 10, that is 2. 2 is the minimum swap required here. Okay, so the bad elements value is 2 here, and the minimum swap required here is 2. Okay, you can ignore this print statement here. Okay, I was printing to see whether I am getting the correct result or not. Okay, so we have the bad element here as 2. Okay, that means the elements would need to be swapped. Okay, so what we are doing here is we are assigning the minimum swap value as bad elements, that is minimum swap required here is 2. Okay, and what we are doing next here is we are assigning the sliding window start index to 1 and end is the window size, that is 4, sliding window size 4. So here we have sliding window start index as 1 and end size is as 4. Okay, and sliding windows end index is at 4. Okay, so what we are doing here is we are again going to loop over this part. So we have written a condition if while end is less than n. Okay, and here is window size less than n is size of the array, that is 7. So while this is true, this is going to execute. So what we are doing here is we are checking if the element present at the previous index of the sliding window start index is greater than B or not. Okay, if it's greater than B, we are decrementing the bad elements value by 1. Okay, and we are checking the element at the end index if it is greater than B or not. If it is greater than B, we are incrementing it by 1. Bad elements value are incrementing it by 1. Okay, so in this case, A start minus 1, that is element at 0th index, is it greater than B? No. And the element at the sliding windows end index, okay, that is index 4, is it greater than B? Yes. So the bad elements value, we are incrementing it by 1. Previously it was 2, now it became 3. Okay, now minimum swap again we are calculating by using the max.min method. We are passing it the argument within the method as bad elements and minimum swap. So our initial minimum swap is 2 and the bad elements we have calculated as 3. So the minimum within 2 and 3 is 2. Okay, minimum within 2 and 3 is 2. So the minimum swap holds at 2. Okay, getting my point here. The bad element here is 3. Okay, so here we have got the bad element as 3, but the minimum swap holds at 2 because that is the minimum value. We are again increasing the start index by 1 and end index by 1. So our next sliding window is going to look something like this. Okay. Okay, so our next sliding window is going to look something like this. Okay, so again we are calculating whether a of start minus 1, that is start is 2, 2 minus 1 n index, that is 11, whether it is greater than b. Yes, it's greater than b, it's greater than b. So we are reducing the bad elements value by 1, so 3 minus 1 is equal to 2. Okay, so 3 minus 1 is equal to 2, and we are calculating whether the element at the end index of the sliding window is greater than b. No, it's not greater. 3 is not greater than b, so this condition is not getting executed. So the minimum swap, that is the minimum between the bad elements, and minimum swap, both are 2. Okay, so it's going to return, so the minimum swap is going to remain as 2. Okay, so again we are moving this sliding window to the right. Okay, again we are moving the sliding window to the right. Okay, so here the start is 3 and end is 6. Okay, again we are calculating these two conditions here. So if a start minus 1, that is this index, is it greater than b? Yes, so bad elements value becomes 1, and the element present in the end index of the sliding window, is it greater than b? No, so the minimum swap value now turns to 1. Okay, so the minimum swap value now turns to 1. Okay, 1 here. Let me just change this quickly so that you won't get confused. Okay, so the minimum swap value here remains 1. Okay, now the start will increase and end index end will increase, and this while loop will not execute further and will return the minimum swap. So the minimum swap required here is 1. Okay, minimum swap required is 1, so we have our answer. Okay, so the thing to note here is, if you follow this logic, so just see what is happening. So here we have bad elements as 2, minimum swap is equal to 3, and here we, in this sliding window, we have bad elements as 3, but the minimum swap retains as 2. Okay, in this sliding window we have 2 bad elements, minimum swap retains as 2, and if you see at this end, we have only one bad element. Okay, in this last sliding window we have only one bad element, so we need to make only one swap here, and as the value of this swap is minimum, previously we were getting 2 and now this is 1, so this is minimum, so we are simply returning this mean swap value. Okay, I hope you are able to understand this problem. So let's execute and see. Let's remove all these print statements here. Okay, let's remove these print statements here, and let's execute and see what output we are getting it here. So the minimum swap value should be 1, so let's execute this. So the minimum swap required here is 1. Understand the approach which I explained here. Please like this video and subscribe our channel. We'll be coming up with more videos in future. Thank you.